So good evening. Good evening. Welcome to our third lecture in the Colloquium series. My name is Linda Vida. I'm the head of the Water Resources Center Archives, and we are the main logistical sponsors of the Colloquium. And as you know, we also have some financial sponsors. Keep talking. And as you know, we have some financial sponsors across campus, and I thanked them last time, so I think I do have a couple of other brief announcements. We do have some material about the archives in the back of the room on a chair, and if you would like to receive email reminders 1 week prior to each lecture, then you can, and if you're not already receiving them, please sign up on our email list. And also, we now have a water blog, and if you go to our website and click on blog, you can sign up to receive announcements about events, new events that are posted on the blog by using the RSS feed. And let's see. Yes, I just wanted to say that because we have such an extensive email list of people that are interested in water, we've been getting a lot of requests across campus and from other people to help us advertise their water events. And we realize that we've been possibly starting to send out more announcements to the Colloquium list than you might want. So that's why we are only going to we're going to reserve the Colloquium email list just for Colloquium announcements, and all other announcements are now going to be posted on our blog. So if you would want to be informed about those other water events on campus or around California, please sign up for the blog. And before I introduce Professor Hanneman, who's going to introduce our speaker tonight, Ellen Hanak, I'd like to remind you that next month in May, we are having Pat Mulroy, who's the general manager of the Southern Nevada Water Authority, and they provide water to Las Vegas. So it should be a great lecture, and it will be held on May 1st, the first Tuesday of the month instead of the usual second Tuesday. So with that, I'd like to introduce Professor Michael Hanneman.
I'm delighted to welcome Ellen Hanak to the campus. Ellen is an agricultural economist by training. She got her PhD at the University of Maryland. While she was getting her PhD, she worked as a research assistant at the Council of Economic Advisors and the World Bank and the Brookings Institution. After getting her PhD, she worked for several years at an agricultural research institute in Paris, focusing on economic development and agriculture in developing countries. In 2001, she moved to the Bay Area to take a position with the Public Policy Institute of California, PPIC, and she's been tremendously successful in putting together a really excellent program in water economics and policy at PPIC. She's done a lot of interesting studies. This is probably the most interesting thing to date. So without further ado, welcome, Ellen.
I know. Okay, I've got a green light. So thanks everybody for coming on an early evening to hear about the Delta. The report I'm going to be talking about is a joint effort with a number of other researchers, all of whom men from UC Davis. So I had a a very privileged position in this team because I was the only person not from Davis and the only woman on the team. They were all very gentlemanly, and it was a lot of fun, this project. This was something that we started back in December of 2005 at a point when both some work that I'd been doing at PPIC and work that some of the guys on the team from Davis had been doing was kind of converging on our thinking that it would be a good idea to have an independent group of researchers take a look at the Delta, both to do an assessment of what the nature of the problems are, and then spring from that into looking at some long-term solutions. And we started this at a point when there was, I'm not going to say chaos. Well, I said chaos just now, but I don't mean chaos. But there was kind of a sense in which the institutional framework that had been set up to deal with Delta problems and to try to fix the problems in the Delta was facing a crisis of confidence, and there hadn't really been anything set up to take its place, although there had been kind of intimations that that should happen. So we thought it could be useful to try to do something quick and dirty to feed into the policy process. So we worked on this over the course of about 9 months. We met on a weekly, bi-weekly basis, and kind of around the table, you can see it's a group of folks from all the sort of the range of disciplines that at a minimum you'd need in order to be able to take an interdisciplinary look at the Delta. And at some points, we also brought in other folks, sort of had workshops with a group of hydrodynamicists, had a workshop with some more biologists to look at some of the things that we thought were important to get additional feedback on. Also, in the course of the work, I did a lot of interviews with various stakeholders to get a reading on how different stakeholder groups interested in the Delta were thinking about the problem and what the nature of their concerns were. So this report ended up being released in early February of this year, and so I guess we're a couple months into this now. And at the end of the talk, I'll sort of go into a little bit of the sort of postscript to what's been happening since then. But it's been an unusual ride, I would say, in terms of the kind of response we've gotten from a policy document. So I'll just start, I guess. I'm going to give you an overview of what the report contains, which I should say, by the way, it's available on our website for download, and also if anybody wants to give me a card afterwards or their address, we can send you a hard copy of it. Major themes, 5 of them, all of which a bit iconoclastic maybe, or at least some of them. The first is that the current way that we're managing the Delta is unsustainable for pretty much everybody that is concerned with the Delta. The second is that there is a basis now with some of the new science that's come out, in particular, an improved understanding of the Delta that provides us with opportunities to think about different kinds of solutions than we've been thinking about in the past, particularly with respect to ways to help correct some of the big problems in the Delta ecosystem. The third message, and this kind of springs from the second one, is that there are some promising alternatives. We identify a number of them, and I'll talk about those in a little bit. Among the promising alternatives does not include the state's current policy. So it means that business as usual is not promising. So even though there's some hope on the horizon, it's not going to be an easy haul in that respect. Fourth message, and this maybe is also some of the new thinking, or a different way of thinking about Delta problems than has been done in the recent past, in the era of what's known as the CalFed era since the early 90s, is that most users of the Delta have ability to adapt to changes in Delta policy. The approach that's been taken for most of the CalFed era has been to sort of say we can all get better together, and no need to have any losers, but also let's not need to adjust much either to the way we're doing business. Let's just try to find fixes that let everybody keep doing exactly what they're doing, or almost what they're doing. And it's our sense that it's not possible to assume that everybody's going to be able to get better together, at least in the way that it's been thought of in the past, but that there is a lot of potential for adaptation, and we shouldn't be afraid of that. And then the final sort of major theme, and this is one that we don't talk about as much in the report, but that has a lot of implication for the policy process that's now underway in the Delta, is that promising solutions, long-term solutions to the Delta, are unlikely to arise from a stakeholder-driven or a stakeholder-only process. And this, again, is kind of in response to the dominant approach of the CalFed era, where there was a lot of effort and very good work done to bring all the stakeholders to the table and to get the stakeholders to talk to each other and attempt to build consensus. It's our sense that that's been very valuable, but that there are limits to that, the nature of the process like that, especially when there are trade-offs that need to be negotiated, that there's a need for political leadership to help negotiate those trade-offs. And also, there's a need for a solid technical process to accompany both a policy and stakeholder process. We'll talk about that a little bit at the end, too. So, outline of what I'm going to talk about, a little bit on why the Delta matters, which I'm guessing probably most of you all, I don't need to say much, but I'll tell a little bit about that anyway, because I think it's going to be important in terms of thinking about how to mobilize public opinion and support more broadly in the state for agreeing to a Delta solution, because the public's going to definitely be called on to weigh in on that in the form of voting for a bond. Or that's the most likely way in which they're going to have to weigh in. So why the Delta matters. Then a bit on the new thinking, both with respect to the ecosystem, so some of the new science on the natural system, and in particular on species, and then also a little bit about what I mentioned in terms of adaptation, the ability for economic users of the Delta to adapt. And then I'm going to go into the long-term alternatives that we highlight in the report, of which there are 9, how we screen them, and then our recommendations. So just first, a quick map, a couple of maps to show you the Delta. Now, the map over here, the nice colored map, everything in color here is what's considered the legal Delta. This was defined in an act of the legislature in 1959. What we talk about in the report also includes this area over here, known as the Suisun Marsh, but at this point, there's really an emerging consensus, and the current policy process is, in fact, trying to think of the Delta as including this area really as part of the same ecosystem, and therefore something that can't be viewed as a sideshow or as distinct, unrelated to the Delta proper. Now, the Delta as a whole, it's quite large. It's close to 750,000 acres, about half the size of the Everglades, for those of you who know your sort of national map and national important ecosystems just close to the water. The color scheme here highlights another important feature of the Delta, which is that a lot of the land lies well below sea level at this point. So everything that's not green, but that's in color, is below sea level. The red is 15 feet or more below sea level. This is a network of about 60 islands that were reclaimed between just after the gold rush that started in the 1850s, and it was a process that was completed in the early 1930s. The land was marshland, peat soils that were drained and with levees built around them to be able to use for farming. So in fact, started with the gold rush, when a lot of the early miners realized that maybe there were better profits to be made in agriculture than in prospecting up north. Now, the fact that this land is sinking and has sunk and is sinking is a very important aspect of why the Delta is perceived to be in crisis today, because all of these islands are protected by levees. And if you drive through, or if you kayak through or go through on a boat, you'll see that on the one side you've got the water, and on the other side you've got the land, a lot of air, sort of corresponding to a lot of that water. So there's a lot of hydrostatic pressure on these levees, and the forces that work over time are expected to basically make this a lot more tentative. The levees, many of them were built a long time ago. They don't have any solid structural foundations. A lot of them would be subject to liquefaction in the event of an earthquake, and just sort of normal everyday things like a beaver or some kind of a burrowing crabs can cause levee failure. So these things can happen just sort of for random reasons, but also with sort of a variety of different forces of Mother Nature at work. So seismicity, we're expecting increasingly high flood flows in the winter and spring because of regional climate change and climate warming, sea level rise, and then the land is continuing to sink because it's continuing to be farmed. So that's kind of a key picture of the levee of the delta. Now, this other map just kind of highlights for you that it's also a crossroads of a lot of different things. This shows you where the export pumps are located. So Southern California's and a big part of the Bay Area and the San Joaquin Valley, their water comes through here to the pumps and goes off to the various directions. That's the thing people think about sort of first when they're worried about delta infrastructure, but you can see there are a lot of roads, there are other kinds of aqueducts, power lines, gas lines, and so on that crisscross really much of the delta. So sort of solving the delta problem is going to require thinking about these things too. And this sort of non-water infrastructure is something that we talk about some, but we don't focus on in detail in the report. So who should care about the delta? Pretty much everybody in California. If you think about it in terms of these various sort of themes that are up here on this slide, water supply is one that is often highlighted just because of the sheer magnitude of the importance of the flows that go through the delta for Southern California, the San Joaquin Valley, and the Bay Area. I think the estimate is that about 2/3 of Californians get at least some of their drinking water from water that goes through the delta, a big chunk of the most valuable agriculture in the state. So water supply for sure. Agriculture, the delta itself is still primarily an agricultural area. So as it was when it was reclaimed, the ecosystem was there before and is actually in big trouble now. And this has been a big part of the focus of trying to find solutions for the delta since the 80s, really. And then on this sort of, on the bottom line here, gives you an indication of some of the things that people have been thinking about much more recently, especially since there's been recognition of the levee problem. And the levee problem has really been kind of on the radar screen in a big way for the last couple of years. One of the authors of this report, Jeff Mount, and together with a professor from Berkeley, Bob Twist, did a paper a couple of years ago analyzing what the risk of failure was to the levees, and found that it was basically about a 2/3 risk of catastrophic failure in the next 50 years. So that got a lot of people's attention. Then Hurricane Katrina struck. That got a lot of people's attention because they realized that we've got a lot of the same kind of issues of bad levees and land that lies below sea level. But so that's gotten folks focused on other things. Now, anybody who lives in the service area of the East Bay Municipal Utilities District, like here in Berkeley, that's your aqueduct that goes right across a few subsided delta islands. So depending on which islands would fail in a catastrophic failure, you guys would be in trouble for water supply potentially if the aqueduct didn't hold up. And that's just an example of infrastructure. Recreation is actually a very important and kind of unsung activity of the delta and is expected to be an increasingly important thing, just given the growth in population all around the delta, basically. We've got 3 major metro areas sort of around the delta. And then housing. Now this is a picture of Discovery Bay. Nice houses right on the water. When folks started worrying about fixing the ecosystem problems and the water supply reliability problems in the CalFed process back in the early 90s, they weren't really worried about the housing issue because it was kind of assumed that the delta was going to mainly stay agricultural. There was some negotiations about that, and that was kind of put off the table, and there wasn't a whole lot of activity early on of that nature, in part because of the nature of the housing market. There was a slump in the early to mid 90s. Since then, things have picked up, and there are now plans for something like 130,000 homes within the delta, mainly around the periphery, but some of that in definite harm's way with respect to flood flows. So that's become one of the sort of new conflicts in the delta, and there are a number of legal actions right now with respect to different housing projects. So 3-pronged crisis with the delta. The levees, which I mentioned, and basically, if there's a catastrophic failure of the levees, unplanned failure where we're not prepared in terms of what we would do otherwise, that could lead to major outages for water supply, in addition to various other consequences of flooding with respect to land use, infrastructure, and so on. It would also not be great for some of the critters that we care about and that are listed on in the Endangered Species Acts. That's the second part of the crisis, which is that there's been a focus on the Delta for quite a while, and there are a number of different Delta species that are in trouble. A lot of the early focus on fixing the problems was on salmon in particular, and some of that's been very successful. In recent years, there's been a crash in the populations of a different class of fish known as pelagic fish. These are fish that live in open water their whole lives. Some of these are native and endemic. Some of them are not, but they're considered desirable species. And some of them are at the point really where there's a risk of extinction now. So there's an acute sense on the part of the fisheries agencies and the environmental community that something needs to be done fast. And then the third aspect of the crisis is the governing institutions. I mentioned that there was this crisis of competence in the CalFed process, and that really partly stemmed from the fact that some of these other problems happen on CalFed's watch, and sort of a question of, well, why weren't you worried or monitoring this and preventing this from happening, but also an inability to agree on how to fund any kind of Delta solution. And I think Michael's been involved in some of those tortuous deliberations on funding. So what's happened over the last couple of years is a resurgence of legal actions. And you've got a number of different groups suing other groups. In particular, the environmental community has basically decided that since they weren't feeling like the process was dealing with these problems with respect to the species, they had to use the courts. And in fact, right now, the state is under the gun because as of, I think, maybe 10 days ago or so, one of these legal actions made its way through court, and an Alameda County judge decided that the pumps would have to be turned off for the state water project in 60 days unless the state got a permit for the Delta smelt, one of the troubled species. So where does the new thinking come in on this? I'm going to start with a little bit about the ecosystem. And the way we discuss this in the report, it really has a lot to do with how we manage water supplies in the Delta. And we kind of came to this in part by looking back through a lot of good history reports, including things found at the Water Resources Archives. So this is a nice little drawing from an artist, cartoonist at the US Bureau of Reclamation from the mid-40s, but it depicts kind of in a cute way one of the huge problems and debates that occurred in the early 20th century over managing Delta water supplies. The fact that if salt water intrudes into the Delta, it can cause major problems for Delta agriculture, and it's also not a good thing for exports of water to south of the Delta. Now, here you can see Mr. Salty kind of moving his way through, all the way through up to Sacramento. Stockton's in the wrong, yeah. He wasn't very good at geography, but anyway. But he conveys well the sort of the nature of the problem with salinity. There was a lawsuit filed by the city of Antioch in 1920 against the Sacramento Valley irrigators, the rice farmers up in the Sacramento Valley, arguing that it was their fault that the water was becoming too saline in the Antioch area and in the Delta. This suit ended up losing at the Supreme Court level. The Supreme Court acknowledged that irrigation might be a part of the problem, but that there were other factors that also had come into play, that came into play, and that there was likely to have been much more of a fluctuation beforehand. But fundamentally, the court basically said, well, Antioch is too small relative to the economic interests of all the other folks who are going to be relying on the waters in the Delta, so we're not going to stop the use of water elsewhere. But basically, as a result of this lawsuit, California policymakers decided, let's just solve their problems as well. And so it was kind of basically a positive outcome of the suit in a way, even though they didn't win it. And the decision that was made was to keep the delta fresh. And this kind of is a schematic that shows you the basic idea. We built Shasta Dam up here. That was the first one. And since then, we've built some others. You use the reservoir releases both to send water through the delta to the pumps and down to folks who are going to use it. And then you also flush the reservoir water out through the western delta so that you basically keep this area to the east of this line fresh. This is the approximate line of what's called X2 now. And what folks called this at the time was building hydraulic barrier, basically using the water pressure and the water flows to keep a barrier of salinity. Now, at the time that this was being debated back in the 20s, it took some decades for the investments to actually bear fruit. There was a lot of discussion about an alternative, and I was very excited. If anybody wants to see a great old map at the Water Resources Center archive, they talked a lot about putting a dam, basically, over there, a physical dam instead of a hydraulic barrier, a physical salinity barrier. And there's a map showing a number of different places where they might have done this. That was actually extensively studied, and they decided that ultimately it would not be great from a flood control perspective or from a fisheries perspective, and it was going to be way too expensive compared to this hydraulic barrier. So the hydraulic barrier was what was chosen, at least as a foreseeable solution for some decades to come. And it's basically become our policy that we've had in place ever since Shasta Dam went online. So the State Water Project relies on the same system, and all of our regulatory body of regulations and law about how we manage the delta relies on this basic scheme. So we've been tinkering at the edges with it, but we haven't, fundamentally, this is sort of the picture. Now, just to kind of give you a sense of what happened before, there's evidence, and it's not, there aren't terrific data records. So some of it is anecdotal, some of it relies on what the early explorers found of the delta, but this is some of the best sort of month by month records of fluctuations in salinity in the delta. And this is records that were kept by the C&H Sugar Factory, which is located right by the Carquinez Bridge. For anybody who drives up 80 towards Sacramento, it's still there, it's still going strong. Well, when they set up shop, they did not have a connection to fresh water. So they relied on barges to bring the fresh water to their plants. And you can see that these kind of track month by month how far from zero, which is where they're located, from Crockett, how far up they had to go. And there were a number of springs early springs where it was fresh there. So they didn't have to go far at all. And as the season wore on, and you got further into the summer, you had to go further and further up. And we calculate that basically in this decade, they were going up to about the level of Rio Vista in the delta. Now, this is in the 1908 to 1917. In the 20s, there were some very dry years, and you also did have more diversions of water upstream by the rice growers. So you had a combined sort of impact of that meant that they had to go much further up, 40 miles in from their location. And finally, they just decided that that was way too much of a hassle, and they sent their barges over to Marin County instead, which is an extreme irony if you think about what happened in 1977. 76-77 was a very bad water year, extreme drought, and there was actually a pipe put over the Richmond Bridge to send water to Marin. So it's kind of the reverse was going on here. Of course, I'm not sure, yeah. Anyway, so that's sort of some of the kind of more detailed evidence, but I just want to show you a map to kind of give you a sense of, give you a sense of where some of these different readings occurred and how that relates to the current policy. So here's the hydraulic barrier, and this is a barrier. It's a barrier for 2 parts per thousand of salinity. So you wouldn't want to drink this water, although it's considered fresh water here. So it's about twice as saline as drinking water. Now, in the summer of 1841, a group of explorers was up here and camped and reported that they had brackish water that they couldn't use. We don't know how far inland at that point they would have had to go for fresh water. in the 1870s, early 1870s, there was a big drought, and a Delta resident reported later, some years later, during some of the salinity investigations, that they had to go all the way up to the mouth of the Mokelumne River for fresh water. This is sort of the approximate location of that first decade from the graph I just showed you. And this was for water that was fresher than here now. So they're not exactly comparable, but there is definitely a suggestion that there was more fluctuation than now. And we've had a certain amount of discussion and debate since this report has been released, especially with folks from the Delta and from the Contra Costa Water Agency, as to exactly what the historical patterns were, given that these more recent readings, you already had a lot of distortion relative to natural conditions, because you had all the levees were built, you had irrigation upstream and so on. So some of these earlier anecdotal things are really better readings of what life was like, but we don't have very many of them. So, and there's an interest in doing some more modeling of this. But anyway, just to sort of full disclosure that there's a debate about how fresh the Delta was. What there's not a debate about is the fluctuation. I think everybody agrees, including the various Delta folks that have been looking at this since our report came out, that there was a lot more fluctuation than there is now. That basically the policy that we've had in place artificially maintains a rigidity. So why do we care about this? It's really not because of sort of nostalgia about things past in the Delta. It's really much more because of thinking about how this fits in with some of the new science on the ecosystem and species. And in particular, this static artificial environment that has been created is very favorable to some of the alien species, the invasive species that are most harmful to some of the Delta species that are most in trouble and that are considered desirable. So I'm just showing you here a few of them. The Asiatic clam and the Brazilian waterweed, these are both freshwater invasives that are extremely harmful to the pelagic fish and their food supply. In particular, they both become stressed when they're subject to saline incursions. And the overbite clam has invaded large parts of the Suisun Bay and does very well in pretty much stable brackish conditions and gets stressed when subjected to fresh water. So, meanwhile, the native species evolved in a much more fluctuating environment, and therefore they do much better than the invasives under those conditions. So the thought is that restoring fluctuating conditions is going to be a key part of dealing fundamentally with the ecosystem problem in the Delta. And I'll just show you kind of a little schematic of which species we're talking about relative to fluctuation. So here's just a little sort of schematic, highest seasonal and interannual fluctuations. This whole sort of group of fish, including a number of them that these three top ones, these four top ones are all four that have had major crashes in their populations in recent years. And the mysid shrimp are some of their food supply, for example. These guys are all invasives. They're not all useless from every perspective. The largemouth bass fishermen like it quite a bit. But what we're talking about is not eliminating them from all of the Delta, just kind of providing some opportunity in some parts of the Delta for them not to invade, basically. So now moving on to adaptation, the sort of the other part of what's new. We're saying that we have to think about adaptation as something that's unavoidable because the current Delta is unsustainable, that all interests are able to adapt to some policy changes in the Delta. And we look at this both through some modeling tools, and also that was part of the work in interviewing various stakeholders, or talking to different infrastructure providers in particular to see what they were doing. What was PG&E doing? They've got a lot of infrastructure going through there, for example. So since we're focusing on water, and just to give you a sense, the available tools for adaptation, there are a number of them, and these really have to do with, these are tools that modern water planners are using anyway in terms of thinking about a portfolio of different supply sources. And the adaptation here is really thinking about, okay, well, lessening your reliance on the Delta, or at least lessening your extreme sensitivity to outages in the Delta by by adjusting in some different ways through water marketing. Interties are a big part of this, especially in urban areas where there aren't connections right now. The Bay Area, that's something that is starting to happen. Conservation, groundwater banking, recycling, desal, a whole gamut. And in the agricultural sector, shifting crop mixes is an important part of that. So what we find is that the economic costs are finite, but they can be large for some users. And I just kind of show you quickly, there are a couple of models that we use for this. One of them is a new one. This is a model that specifically looks at agriculture in the Delta and what would happen under changing salinity. We're interested in this, especially if one moves to a more fluctuating salinity regime. And this one just shows you sort of current revenue levels per acre. Yeah, thousands of dollars per acre in different parts of the Delta. And one of the key sort of take-home points that's kind of interesting here is that actually already now the parts of the Delta where we would think about introducing more fluctuation are the parts that have a lot of the lowest value agriculture anyway. So it's not the most high value ag. And what we find is that increases in salinity in parts of the Delta would definitely reduce profits and put some folks out of business, but large areas in the Delta would likely not be affected by that. And then the sort of more statewide assessment of water user adaptation potential is a model that Jay Lund and Richard Howitt have used in the past called Calvin, which basically allows you to look at a number of different ways of managing water and optimize that over the whole statewide water system. One of the key findings of this work is the extreme importance of maintaining the statewide system and keeping connections between the North and the South. So why we need a new Delta policy? This was a slide we gave to the legislature a couple weeks ago, so I'll just sum up for you too. All interests are getting worse together with the unsustainable policy that we've got now. Delta failure, a catastrophic failure would be disastrous from a number of perspectives. There's better ecosystem understanding that points to promising solutions. Stakeholders do have a potential to adapt to new solutions, and that's probably a better thing than continuing with the high-risk strategy that we've got now. And promising alternatives exist. So now I'm going to show you the alternatives. We looked at 9. And we basically tried, these are 30,000-foot alternatives. These are not detailed engineering proposals. It's really kind of a way to start thinking about things. And we wanted to include the current policy, but then also look at some of the policies that have been considered in the past or some new variants of those. So we've got 9 in three groups. The first 3 are what we call freshwater delta. So these are policies where you would aim to maintain the policy that we've had in place ever since the 40s, but maybe do it a little bit differently or bulk it up some to try to deal with the levees. So there are a couple different levee-based alternatives. And we also do look at the old solution, the physical salinity barrier. Then we've got 3 that we call fluctuating delta. And these are they're solutions where you would basically change your water management so that you allow fluctuations in the western and central delta, but you don't reduce water exports. So you find some other way of moving the water to the south. So that gives you a couple of different peripheral canal alternatives. And I'm going to show you maps or pictures of all these in a minute. And something we call an armored island aqueduct, basically a canal through the delta. And then finally, we've got 3 reduced exports alternatives. These are all also fluctuating allow fluctuation in the western and central delta, but they are different in that they're not very infrastructure intensive, at least not infrastructure in the delta too much. A couple of them allow continued exports, but on a more opportunistic basis, because the delta will always have some periods, and especially certain years, where there's going to be a lot of fresh water, even if your levees are not in great shape. So the idea is that you export when there's naturally there's a lot of fresh water, and you don't when there's naturally not. So you don't maintain that hydraulic barrier. And then finally, we also examine as a bookend what happens if you abandon the delta altogether for exports. So just to kind of go through these, levees as usual. This is the current policy, and what we're assuming here is that we would make the investments more or less what was planned under CalFed, but what wasn't done. So $1 billion to $2 billion in fixing up the levees, but not with fundamental changes in the policy. That goal is basically 100-year agricultural levees. So it's not levees that would be good enough for people to live behind. And given the various forces of nature at work, it's we assess that this is probably something coming with increasing risks of failure despite these investments. This is just a picture of a Sacramento River levee, which you can see is, nothing special, nothing very bulked up. The second levee alternative is saying, well, okay, instead of just, kind of doing a bit with the levees, let's get really serious and sort of go Dutch style with the levees, do something really, really massive. So, including maybe some structural reinforcements. And I know, Ray Seed was in your speaker series in the fall. There are, I think, debates, he's talked about this some, as to whether or not it really is possible to seismically retrofit levees in this system. But, let's assume that maybe it is. And that's kind of what we're thinking about here. But certainly you do a much better job in terms of the heights and everything relative to sea level rise and relative to flood pressures. And what we find is once you go this route, there's no way that you're going to invest in all the levees in the Delta, because 1,100 miles at the kind of cost, I think we figured it'd probably be about $10 million per mile. You're not going to be able to do it, so you would pick strategically which levees you would do. And this is kind of our artist's view of which levees would get fortified. They're in red. So what would this buy you? This would let you urbanize in certain places protected by the levees. You could strategically protect certain other infrastructure. You would do this, of course, to keep your water supplies intact. But what you would lose is a lot of the Delta land use, because you wouldn't be dealing with the levees that are not strategic, and eventually they would flood. So the seawater barrier, we initially started looking at this just as a sort of historical curiosity, and then as we were finishing up the report, newspaper articles started showing up about how Dutch engineers had been roaming the Delta and talking to folks and saying, you guys could do a physical barrier to protect the Delta, and because we've done this in Rotterdam and other places. So this got some people excited, so we thought, some things never die. They just go into hibernation for a while. So this shows you the Rotterdam movable storm surge barrier. It's something that could be done. It gets some engineers excited. It's something that would be in a lot of ways like the Fortress Delta, in that it wouldn't resolve the land use flooding problems within the Delta. And there are questions as to how well it would work against seismic events. So now switching into the fluctuating Delta alternatives. These are the fluctuating Delta with sort of some kind of new conveyance infrastructure and moving water differently. This is a map of the peripheral canal that was taken to the voters in 1982. Very contentious at the time, and it lost. But the basic idea, there have been a number of different proposals over the years since the 40s. The basic idea is you take water from somewhere on the Sacramento River and you bring it down to the pumps. And the exact size and design and everything, those are all details to be worked out. Why we think it's interesting to look at again is that it does allow you to break the relationship between exports and water management for the ecosystem, because you would be able to have fluctuation in here. Now, just to kind of highlight that peripheral canal could come in many different colors and versions, our second alternative, this is something new in terms of thinking about how to do it. Instead of taking the water straight to the pumps, the idea here would be you would take it to the lower San Joaquin River and then allow the water to come back out and flush. The South Delta has terrible water quality problems, and so this is something that could allow you to deal with many of those problems. At the same time, you could build in some wetlands which likely existed before, flood bypass and so on. So there could be a lot of ecological benefits to this. It would come at the price of the water quality for Southern California not being as good, because it would get some of this water that's not such a good quality mixed in with it. But anyway, it's an idea of a little different way of thinking about it that might give you buy you some other things. And then the third conveyance option is building something right through the Delta. Basically, where the water moves now, you armor those channels, you widen some of them, and basically puts you in a situation where you have fluctuation over here. This has some potential drawbacks in terms of you'd have to work out how you get the ships to Stockton, and you'd have to work out how you make sure the salmon can get through. but you know, it's not something that is a non-starter from those perspectives, at least at our 30,000 foot view of the problem. This was actually something that was talked about in the early 80s under Duke Majan. It was called Duke Stitch. So then the reduced exports alternatives. Here the idea is that you only pump at some times, you don't make major investments, except possibly in storage near the delta. And the reason for that is that when we're limited in how much we can pump at any given time. The canal capacity, the aqueduct capacity south of the delta. So if you've got a really wet season, you might want to take some big gulps of that water in storage areas near the delta so that you can send it down over a longer period of time. And so we've just colored in here in red 3 of the recent storage proposals. You know, we didn't invent these, so these might not be the optimal ones, but they're ones that folks have looked at of near delta storage. Now what you get with this is, you know, fluctuation in the ability to have fluctuation here. You would get some more flooding, most likely, within the delta itself. The EcoDelta is basically just a variant of this opportunistic pumping idea that is taken to its extreme, where you basically think of the biologist as managing the pumps. So the ecosystem values are the predominant reason that you're managing the delta, and water exports are incidental. So when there's really water that is not going to pose any trade-offs, that's when you can send it down. What we've done here in this map is actually something we could have done with a lot of the different maps, which is to highlight that it makes sense to think about the delta land use from a much more heterogeneous perspective too. So here we're just showing sort of different types of ecosystem land management, but you could think about that for a lot of other alternatives too. And that's something where, you know, in a way we've been managing the delta water from a homogeneous, stable perspective, and we've also been thinking about delta land from that perspective, and that's probably not the best way to think about it. So abandoning the delta, you know, supposing everybody just decides it's too unreliable, Southern California decides to divest and, you know, focus on local supplies, you would end up getting a lot of flooding. You know, there are people actually, there are environmentalists in Southern California that really kind of are thinking more and more in that direction, I would think. Maybe not complete abandonment, but certainly reducing dependence. So here the thought is that you would also end ecosystem investments. So as a result, the ecosystem performance is not great because you'd have really bad water quality issues down here. So screening. You know, there are many different ways you could evaluate these alternatives, and we kind of decided we would go with our strengths. So we focused on ecosystem performance, and especially deriving from this sort of the conceptual model and the thinking that I presented to you earlier. What would you get in terms of water exports, and then some of the economic and financial costs. And these are not all. This is not what happens to Caltrans, for example. It's really focusing on water issues. So what would happen within the delta for agriculture, the cost of export adaptations of various export users, and then also some estimates of investment costs. And the investment costs, we really relied on existing studies and kind of scaled things up with standard inflation calculators. And we think they're low, but you know, they're probably useful in comparative purposes. Other delta services, how it would perform, we talk about that some in the report more in a qualitative way. And this is the summary table. Green does not mean go, it just means keep on the table. It means promising. And the sort of pink is pink or red is unpromising. And what we find, we're sort of looking across these 3 categories, is that basically the five highlighted there from 4 to 8, all of which allowing fluctuations in the western and central delta are most promising and merit further look. Now, just to kind of explain this one to you a little bit, in terms of the economic and financial costs, the top line is investment costs, and the second line, when there is a number, is annual costs to water users in terms of scarcity of water. So, or scarcity or increased operational costs. And we think that the investment costs are probably low by a factor of 2 or 3, just given recent cost overruns, which have been rampant in California and really elsewhere in the world over the last decade or 2. We think that probably the annual costs are also low, maybe by a factor of 2. But you know, as Michael and I were talking about this earlier, even if you think that they're higher, it gives you a basis for sort of comparing the alternatives, because they're probably in relative terms, the methodology is standard. So just what do we throw out? We throw out the abandoned delta as just being too costly to water users, and it doesn't really do much for the environment either. And we throw out all three of the freshwater systems as being lousy for the environment, as is good evidence of that by recent, well, the performance up till now, but then also not great, some of them not great from the point of view of water exports, in particular the levees as usual, which is doing fine for us right now, but could fail at any moment. And actually, if the pumps get shut down by the judge, it's not doing fine for us because of the ecosystem failure. So it's kind of risky from all perspectives. So recommendations. We came up with a set of short-term and a set of longer-term recommendations. So I'll kind of just go through the key ones. In the short term, we tried to come up with a list of what we call no regrets short-term actions that you would want to take no matter which of the alternatives you would end up going with in the long term. And there's recognizing that putting in place a new long-term alternative is going to take a while. So, you know, in the meantime, we have some serious issues, including fish crashes and urbanization and whatnot. So, what do you do to kind of arm yourself in the interim or prepare? First on the list, emergency preparedness, which is starting to happen. Especially some of the key infrastructure providers are really getting savvy about this. And you know, water users, urban water users, are getting a lot savvier about this. But there's still no real flood response plan for the Delta, much less for the Central Valley more generally, as an example. Or you know, putting in place, what do you do to sort of block the intrusion of salinity if you do get a catastrophic failure? And this is something that a number of the big water agencies are starting to think about now. Second, we're suggesting a do not resuscitate list for some islands in the Delta. And the idea here is that if they fail, don't necessarily come in with a helicopter with the governor and lots of money to follow. You know, that was something that one of the ways that levees got a lot of attention in as of 2004 was that there was a massive failure of one particular, a levee on a particular island, Jones Tract, in the summer. And this was when the governor was really just getting interested in infrastructure. You know, came out and said, we've got to fix it. And then, you know, given that we didn't have a plan, that was a smart strategy, because you can have a domino effect in no time if you've got the wrong levee breaking because of wind action and so on. So that was fixed. It turns out to have been, I don't know, the estimates suggest maybe 2 to 3 times more costly than the value of the land on that island. So now, as a result of that, folks have really started thinking, well, okay, maybe we need a plan for which ones are strategic and which ones aren't. What we're suggesting is that it could also be a useful way, potentially, of thinking about moving into some different uses for some of these lands, maybe for some ecosystem purposes. If you have a plan, if something's on a list, you can think about, okay, well, this island's going to be converted over to a certain kind of wetland management or something. So third, Delta land use. You know, there are all these houses that are waiting. Well, some of them are in the process of being built or almost being built or waiting for a court decision to go forward. We think that there's a real mess right now in Delta land use, or really kind of very fragmented decision-making process with small towns and unincorporated areas managed by counties, with pressure, fiscal pressure to urbanize. So it's very hard for them to say no. And there's not really anybody minding the shop on flood control in the way that it ought to be done in terms of what kind of risk they're putting themselves at, or what kind of risk they're putting other people at. Because you raise your levee, you're making it worse for the guy next to you. So it can lead to this sort of battle of, you know, having to do competing levees in order to keep that going, and it needs to be dealt with at a regional level. Also, habitat protection. This is an area where, you know, in the Bay Area or in Southern California, if you're going to build a development project in an area where there's some sensitive habitat critters that you are worried about, you have to take that into account as part of the environmental review process. And that's thanks in part to the environmental laws, but it's also thanks to the fact that you've got citizens groups that are really watching this stuff. There's not really that kind of pressure in the delta, at least not from within, part because it's not well inhabited, and that's not kind of the local priority. So you do have some of these lawsuits now kind of coming in, but what we need is a process to make sure that there's habitat protection being done. And so what that might mean now in the short term is getting an assessment of what would really be important to save and buy it, or find some way to protect it before it gets before it gets hardened. And then final on the sort of short-term list we identified some places where you could do projects right now for some of these pelagic fish that are in trouble. So steps needed for a long-term solution. And these are steps that need to be taken now in order to get us to a long-term solution. It's not things that need to be done in the long term. We say that it makes sense to start by focusing on the promising alternatives and throwing out the ones that aren't promising, because there's a limited amount of brain power to go into this, and political energy and so on. So start with the promising and weed out from there. We think that there's not yet a technical track to explore solutions, and it's really important to do that. There's a lot of good science done in the CalFed era, but not really a kind of problem-solving team from an interdisciplinary perspective. We think that's what's needed now. Third, we think that there's going to be a need for some kind of overhaul of delta land use regulation in a more comprehensive way. And there's some models of that have been pretty successful in California, including the BCDC, Bay Conservation and Development Commission in the Bay Area, which has been around and very successful in keeping the bay from shrinking from landfill. The Coastal Commission is another model. We also talk a fair amount about financing in the report. This was one of the Achilles heels of CalFed, not being able to get beneficiaries to agree to pay, even though they agreed in principle to this. We talk about some ways to get some upfront commitments for this before saying what we're going to invest in as a state. And then as part of the financing, we also talk about mitigation mechanisms, which is something that really wasn't part of the CalFed world, because everybody was going with the idea that everybody would get better together, therefore you wouldn't need to mitigate. And in fact, we think that under any of these promising alternatives, some folks are going to lose out, in particular farmers in the western and central delta who are going to have more saline water in their areas, and also the Contra Costa Water District, which would be affected. So those are examples, but not the only ones, of folks that might be disproportionately impacted by some of these things, and mitigation makes sense. So I'm not going to go into this. I think just we've been talking with folks since the report came out about the details of what the technical track would look like. We've now given it a name. All of these elements are in the report, but it didn't have the name Delta Solutions Program, DSP. That's what we think they need. And then I just want to kind of wind up with a postscript on the reactions to the report. So this is, I think, the 30th time I presented this report in the last 2 months. We've been all over the state. Jay also has been doing this very actively, and some of the other authors as well. So it kind of came at a point where there was a tremendous policy interest in doing something about the Delta, and in some ways a vacuum on how to start thinking about that. And I credit a lot of the success really to that vacuum, more, maybe to the content of the report too. We'll give ourselves some credit, but part of it was timing. And there is definitely a sense that there's action now underway that wasn't happening before the report came out. The Delta Vision process that was established in law and by executive order back in September. This was an idea of setting up a team of wise people to look at the Delta and come up with a solution. That was kind of languishing and with no names being announced for quite a while. And on the day that the report was released, the Blue Ribbon panel was announced, and Berkeley's own Ray Seed is a member of that panel. But we certainly don't think our report led to the creation of the Blue Ribbon panel, because that was already in the pipeline. But it probably helped to push the administration to move ahead with that. And in some respects, perhaps because we took some risks about what we were willing to talk about, so we made it in some ways easier for the policy makers to to move forward too in terms of their discussions. Now, in the legislature, there was a joint hearing of 4 committees a couple of weeks ago on the report, and it involves some other folks too, including there's the Berkeley Initiative on Land Use in the Delta, which has also been important in thinking about some of these heterogeneous land use issues in the Delta, participated. As a result of that hearing, Senator Simitian's bill, which has been around since the last legislature, proposing a peripheral canal, and was kind of viewed as a placeholder and something that wasn't going to go anytime soon, has now gotten a lot of interest, and it's been changed in some fundamental ways. So now, instead of just proposing what they call an isolated facility, a peripheral canal, what they're proposing is that one should look at these 5 alternatives that we consider promising, or some hybrid solution of those. And they've also altered the timeline to allow time for some short-term science to be done in order to help refine that decision. And significantly, this bill is co-authored now by 3 other important senators. So Senator Parada, the head of the Senate, Gerald Steinberg, who's the head of the Natural Resources Committee, and Mike Machado, who is the senator who really has jurisdiction over most of the Delta. So, and more broadly, I think there's been a shift in the policy debates, in part because we said stuff that people were not willing to say, except maybe behind closed doors. So it's made it okay to talk about a number of ideas on the Delta that were off limits before in some ways. And that's both about the types of solutions in terms of bringing the peripheral canal back onto the table, for example, but also in terms of things like, we're not all going to get better together necessarily. Maybe we have to think about mitigation instead. And so in some ways, it's my sense that it's freed up the conversation. Now, just to highlight that I think there's going to be a lot of work to be done, both on the science side, but then and as part of the policy process, there's also going to be important work that has to be done at the political level. And to highlight that, this is a map of how California voted for the peripheral canal in 25 years ago. So even though Southern California had a majority, it wasn't nearly as strong as the majority yes. In Southern California, it wasn't nearly as strong as the majority no's. In Northern California, I think any solution that tampers with the status quo is going to need to be communicated to the broader public as something that is going to be valuable for a majority of the people. And with that, I'm done.
We have about 20 minutes or so for questions. Why don't you select the questions and answer?
Okay.
So, is the microphone going to...
Or I can just repeat the question. So keep your questions short so I can repeat them without making them wrong.
Did you consider the removal of Friant Dam as a possible means to improve water quality in the South Delta and possibly alleviate the need for a peripheral canal? And if you didn't, why not?
So, no, we didn't. What that could do is help with South Delta water quality, and it could certainly help with ecosystem values in the lower San Joaquin. It wouldn't resolve most of the risk factors that we're focusing on, which are having to do with the levee instability and what that means for water supply, but also having to do with the habitat for pelagics, which is really more about what's happening in the Western Delta. So we've had questions about, and I didn't repeat the question. The question was, do we consider looking at the removal of the Friant Dam and whether that would obviate the need for a peripheral canal? The settlement on the San Joaquin River, which has been worked out, which will be allowing more flows into the San Joaquin, is also something that we don't think is importantly affects our conclusions. Sir?
I'm a little troubled apply this do not resuscitate idea to some of the islands. Doesn't that amount to a governmental taking? Because
okay.
I mean, if you've got a property where they're not going to fix it, it's immediately worth, well, as much as you can float a boat.
So I should. So the question is, does the do not resuscitate list imply takings? And the answer is pretty simple. It's no, because these are, for the most part, private levees, which the state has been providing some subventions for because the state's seen it in its interest to help keep those levees in shape for maintaining the water supply reliability in the delta. But in terms of protecting that land use, no, the state has no obligation to that. That's private land.
Who owns the levees?
Those are private farmers and reclamation districts that own them. Within the delta, you've got about 1,100 miles of levees, of which 400 are considered project levees and part of the state and federal Central Valley flood management system. But the majority, especially in the interior of the delta, are private. So, yes.
There were 2 water quality measures on the ballot last year. I think one had to do with water quality, the other one was Proposition 1E that dealt with levees. How did those affect?
The bonds. Okay, so there 2 bonds were passed as part of the bigger infrastructure package on the November 06 ballot that both deal in part with flood control. Prop 1E is all about flood control, and it sets aside, it's a little bit more than $4 billion total, of which $3 billion are earmarked for the Central Valley in particular, and a big chunk of which is not tied to anything and therefore could be used in the Central Valley. None of that specifically earmarked for the Delta, although the Delta is within the Central Valley, so it doesn't preclude using money there. Prop 84, which was a voter initiative, is about a lot of different water things. I think it's like a $5-point-something billion. About 800 million of that is for flood management, and I think 250 million are specifically earmarked for the Delta. What this means is that there is a fair amount of money available now to allow the state to be doing some things on flood management that it hasn't been able to do, and that normally is part of sort of federal fiscal financial responsibility, but the feds don't have the money. So basically, the governor took the initiative and said, we'll see, we'll do it, and we'll see if we can get paid back later, but we don't want to wait until we get federal money for this. To give you a sense of where it fits into the total flood cost picture, it's about 1/3 of maybe what is estimated to be needed for Central Valley flood needs to really put us into a situation where we've got better protection. After Katrina, it was highlighted that, partly we got highlighted that we had a Delta problem, but we also became aware that we had a Sacramento problem. And Sacramento has about 1/3 of the level of flood protection that New Orleans had. And it's, as a major metropolitan area. So there's a lot of need for that funding for things besides the Delta. What that means is that there's no way that this money could provide you, relative to the numbers I showed you on cost for the Delta, it's not a Delta solution. You might be able to get some contribution towards some short-term measures, and maybe even some part of a longer term, but just a small down payment. Michael.
Just to follow up on that, even though the whatever it is, $8 billion in those 2 propositions is not intended for the Delta. The cost figures you gave were maybe for investments were maybe $2 to $4 billion.
Yeah, so double that.
So double that.
Triple it.
4 to 8. But that says that the state has just raised the sort of money that would be needed to pay for the Delta to use for other things.
Right.
And so you could say maybe if we could raise $8 billion for other things, we could also raise $8 billion for the Delta if we wanted to do that.
Right. So Michael's suggesting that the recent success on the November ballot with infrastructure bonds suggests that there is potential to fund a Delta solution with infrastructure bonds. And I guess the reason I would hesitate in agreeing with you is that these are pre-partial costs. They're basically the water infrastructure costs. They're not anything about the ecosystem restoration costs, and they're not anything about some of the other infrastructure costs. And it's our sense that you want to be careful to do this in such a way that you get ratepayers to pay for as much of it as possible rather than taxpayers. And you know, it's our sense also that there really is a willingness for folks that are looking at improving their reliability to think in those terms. And there are some pretty straightforward ways to do that. Where it gets harder in terms of thinking, you know, who should pay, public or private, you know, taxpayers or users, is in the sort of gray areas of environmental. You know, where do you say that it's the folks who messed up the environment who should pay and therefore be ratepayers, or do you say that that's a public good? And that's where I think you want to reserve the bulk of your public money, because I think it's harder to win those fights. Yes?
I would like to ask the reason why did you make the first delta and the invasive so central to your analysis? Because I could see the same scenarios without being this upfront. Because, for example, many of the problems of the delta for the fish relate to pollution, to increased water exports, and so on. Fish is not only the only ecosystem concern, so there are also birds, there are the vegetation, and so on. Right. So it's related to invasives and fish, and I would like to ask what's the reason for that. And a related question is, what if your analysis, which is based on historical anecdotal data, is wrong? Because we know as scientists that we can always be wrong. How does precaution come in your different visions? Because if you build the peripheral canal and then the fluctuation analysis was wrong, the peripheral canal is there. Okay,
so the question is why the focus on fluctuating salinity, how robust is that really, and what if we're wrong? In what I presented, I focused on that probably more than what you'd see if you look in the detail in the report on, especially chapter 4 that goes a lot into the ecosystem and habitats. And the idea there is really much more about building on the habitats where the desirable species do best. And we focus more on aquatics than on terrestrial, but we do also talk, one of the reasons we think that it's important to protect habitat is it's upland, it's for terrestrial. So I mean, there's a complex set of ecosystem problems that are at threat by the forces underway now. The focus on solutions, promising solutions that allow for fluctuation, in part is because we think that there is pretty good evidence both from this system but also from a number of other systems in sort of modern thinking about ecosystems that allowing fluctuation is likely to be beneficial. There are very few invasives that do well in a fluctuating environment. Invasives typically, they either come in, you know, in ballast water, or they come in from the aquarium trade, and so they tend to like, you know, one thing or another. So we think that from that perspective, the risk of, it might not succeed. It might, you know, the Brazilian waterweed might be too tenacious, or but there's not likely to be a lot of new risk with that. Now, if we were just talking about that from the point of view of let's just do this big ecosystem experiment on a grand scale without really having other benefits, it wouldn't make sense. But given the tremendous risks to the system for water supply at this point, with the current way that we're operating, even if we're wrong about that being a sort of important necessary condition for restoring species, desirable species, we'd still get a lot of benefits out of those alternatives. Is that? Yes?
Back to the San Joaquin side. Under current management, the full flow of the San Joaquin is entrained in the pumps except for April 15 to May 15 during the event period. And I'm wondering about your EcoDelta and some of the other sort of export reduction scenarios. How many months sort of is there still net outflow from the San Joaquin side and that kind of thing?
That's why we need a Delta Solutions program, because we're at a level of analysis where now you need to get some hydrodynamicists working on this problem, and together with some of the biologists to be looking at precisely. That's a question. So sorry, I didn't repeat the question about. I'm not going to be able to summarize it. What changes in management of the San Joaquin River might be implied with some of our scenarios? We think that it's going to be important to look at some of the details on the hydrodynamics with respect to that kind of issue, but even more importantly with respect to what you can do in the western and central delta. So what kind of fluctuation would you really need in order to get the kind of benefits to the ecosystem that we think you could get? But then also, how much fresh water do you need to keep in the delta if you were going to be diverting, so through some kind of a canal? Those are important questions, some of which can be answered relatively quickly. Sir?
I guess I'm curious as to what the next step is. It sounds to me there's obviously an opportunity for enhanced analysis and fleshing out how much some of these alternatives would really cost, better estimates, but also other infrastructure needs and so forth. And also, I'm wondering whether your team has thought about what might happen to these alternatives as they enter the political process. And for example, I take your point that the do not resuscitate idea might not legally incur a taking, but politically it probably does incur a taking. And so that adds to the cost. And a lot of these things, I think, could very easily spiral to a point where it wouldn't be a question of who pays, that everybody would pay, and the answer might be everybody thinks they're paying too much. So
it's going to be hard for me to summarize this
question.
No, I can answer it. I'm just trying to think of for the person recording, sort of what's likely to happen now, and particularly once you get politics kind of intersecting with this process. Let me first say what the deadline is for something to happen politically. It's relatively short. The Delta Vision group has until the end of this year to provide some sort of a preliminary sketch of where they're heading, and then the end of next year to come up with basically a recommendation on a long-term strategy. And that pretty much dovetails now with what the legislation is also telling them to do. You've got a number of, several key legislators that are very important on water that are going to be termed out at that time. And so I think, they're highly motivated also to get something going, and arguably that's true for the administration too, given their sort of strong infrastructure focus now. So there's political momentum. I guess the question that we've wondered is, can that push us toward a solution too quickly? Maybe, and we're encouraged by the way this new legislation is written, where it does at least give some breathing room for some of at least some of the work to be done that could help you to make some of the early decisions without being completely wrong on it. Where do the politics come in? And in particular, the question of I guess mitigation is where I think about. So do not resuscitate list. When we're saying it's not a taking, we're not necessarily saying you wouldn't want to compensate, because there's there are reasons for mitigation that have to do with fairness, and there are reasons that have to do with making something palatable. And Delta agriculture has come to expect something, even if it's not legally required. So probably it makes sense to have some compensation available to farmers, much like we have flood easements. That was an important part of Central Valley flood control policy back in the early 20th century. I don't think that's likely to be the biggest ticket item. Making Delta land, purchasing Delta land, it's not especially high value land. So But that gets back to Michael's question as to sort of where should we be using public funds. I would like to see public funds go for that and not for a new conveyance system, if that's the alternative that we go for. Yes?
You state that urbanization is like the latest, greatest threat to the Delta. But then in the report, you also say that it has the ability to contribute financially and politically to solving the problem. Could you explain that a little bit?
So what's the role of urbanization, and what do we mean by saying it could contribute to the problem even though it's a threat? Could contribute to the solution even though it's a threat. This gets back to the issue of thinking about the Delta land management in a much more heterogeneous way. And it's a pretty big area. There are likely to be places where, there are places where housing already exists and where it might not, you're going to probably have to protect that anyway, so you could, there's no reason, unless we're going to say we're going to kick everything out of the Delta, that's not realistic. So there are places where we think it probably could be viable as long as you have a decent flood control policy and as long as you have a decent habitat protection system in place. Why we think urbanization can help contribute is, well, we think it has to contribute. If it's going to happen, it has to contribute financially. And in that sense, there's no reason for a free pass for levees to protect development, especially new development, any more than there is to help Southern California or the Bay Area tighten up its reliability of supplies. The political part, I guess the thought is there that some of the biggest supporters now of moving toward thinking about different solutions are water users, and that's because they have an important economic stake in the Delta, and that could be true for some urbanizing areas too.
So when you talk about that it would be a user-driven system, then if you're talking about the peripheral canal, would that be something that you envision would be financed mostly by Southern California water users?
So if the long-term solution was a peripheral canal, would that be financed mostly by Southern California? The main users are likely to be Southern California urban areas, Bay Area urban areas, and San Joaquin Valley farmers. One thing to think about is whether they should all pay the same price per acre foot or not. And we talk some in the report about why you might not want to make them pay the same price. And it has to do with the fact that the demand elasticities are not the same, and urban users are willing to pay more for it. And you might actually get a more efficient pricing solution by acknowledging that and letting the ag users pay less. That said, there still would have to be basically a check on how big the canal could be from an ecosystem perspective. And so one way to think about that is allow the canal to be big enough to accommodate really wet years. If at the margin it doesn't cost a lot more to make it a bit wider, for example, right? And if the main cost is sort of the fixed cost of doing it, but then allow that surplus in size to be managed by the environmental agencies, for the fisheries agencies, for example, so that you have safeguards. So there are different ways you could build that in. Yes?
I don't know, SB 27 moved out of committee passed today.
It did? Oh, thank you.
So let's move it.
Thanks. I didn't.
It's the amended version.
So the comment was that the SB 27 did move out of committee. I didn't turn on my Cal channel this morning. Thank you. So.
We should
wrap up.
I think we owe Ellen a warm round of applause.